Good morning, good morning. Hello. Hello to the one person who's live, and hello to the people who are signing in later and watching the videos. Good morning. Just gonna put some stuff on the website. I'm gonna put this link to this very video on the website as we speak. It's not really something that I can do beforehand. It's kind of annoying. I have to start the video and then I have to go onto the website. It's a slight interruption, but it's not the end of the world. Okay. Oops. Okay, embed, paste. There's the video there. Scroll this up. Oh, and the thumbnail of this video has my tongue sticking out. Fantastic. Although I think the thumbnail does change throughout the video as it goes live. Oh, good morning. Okay. I have very special news that I'll share with everyone once we're all here. Very exciting news. Okay, good morning, Dahlia. Okay. Okay, I got 5 people. Let's see if we can wait for 10 people before we jump into it. Yeah. One sec here. Good morning. Okay, let's see. Yeah, I could do that. Mm-hmm. Okay, cool. Yeah, all right. Okay, we've got 8 people. I'm really excited about the news that I'm going to tell you. It's very exciting. It has to do with Goose. Good morning. Okay, how are we doing here for... Okay, we got 10 people. Yeah, you're welcome to stick around, trading, whoever you are. Yeah, you can come hang out with us. It's going to be fun. Okay, let me get Goose. Come here, sweetie. Okay, big news. Today is Goose's 3rd birthday. She's 3 years old, and she's really excited. She's never been 3 before, so it's a big day for her. She's a little bit nervous. She doesn't know what her 3rd year is going to look like, but ultimately she's pretty optimistic. We've been talking about it all morning, but she is a little bit nervous, right? 3 years old. Can you imagine that? Oh, Goose, it was just like yesterday when you were just a little kid. Okay. She kind of does look like a little kitten, right? She's pretty small. She acts a lot like a kitten, but 3 years old, that's you're kind of like a full cat now, right? 3 full years. Yeah. Happy birthday, Goosey. Yeah. All right. Yeah, she's going to have the best day ever. In other news, it's also do a kickflip day, April 29th. You can look it up. It's worldwide do a kickflip day. Very, very special day. Maybe later I'll do a kickflip for you at the end of class, just for fun, just to have some fun. Okay, I think we're pretty much ready to go here. What I thought we could do today is do just a few more examples, and I realized I haven't given you very much homework for this unit. So I'm going to do several examples while Goose shows you her beautiful bum, her birthday bum, and then I'll give you some homework, and you guys have an assignment to work on. Oh, and now Goose is just all over the iPad, just rolling all over it, pressing buttons, all that fun stuff. Hi, Goosey. Yeah, you're the center of attention today. Today's your day. Absolutely, it's your day. We wanted to get her some like special cat food, but her sister Kima has all these allergies, so it's really complicated giving them fancy treats and that kind of thing. So I think we're just gonna play with them today as kind of a little special birthday treat. Right, Goosey? Okay. All right. So yeah, what were we doing? What were we in the middle of? Oh yeah, no, this is the wrong class. This is a calculus class. Goose wants us to do calculus. Apparently, she thinks it's more fun. Okay. So I think what we'll do is we'll just do some examples together. I'll do an example. You'll do an example. I did post the review worksheet that I gave that to my grade 9 class a couple weeks ago. Let's see here, grade 10. Where's grade 10? Yeah, I put it up. What was that? Yesterday. So yeah, yesterday there is it's a systems of linear equations worksheet. And maybe what I'll do is I'll do a little bit of a warm up. And I'll do a couple questions from there. Let's see here. So we'll do a warm-up. We'll do a question from that worksheet. Where are we? Where'd it go? Number systems? No, I don't think so. No. Where did it go? Oh, linear. Yeah, here we go. Okie dokie. So yeah, let's do a question. I don't want to do one of the graphing ones. On the assignment here, why don't I quickly open up? You know what? No, I'll just copy it. I'll just copy it. Okay, so I'm gonna do question 5. I'm gonna do question 5 from the systems of linear equations. So systems. Ooh, that's too thin. So we're going to do the systems of linear equations worksheet. Okay, so this is the review worksheet that I put up just in case you're struggling a little bit. And we're going to do question number 5. And question number 5 is the following. You have y equals negative 3x minus 2, and we have y equals negative 2x. Okay, so we're going to solve this using substitution. So we'll solve using substitution. Okay. That's what we're doing today, is we're going to solve this system using substitution. So, like the first thing that we should be doing when we're thinking of substitution is we're going to say, okay, which variable are we going to substitute into which equation, okay? So the gist of it is that we are going to solve for one variable and put that variable into the other equation. Okay, so what I'm going to do is I'm going to name this equation equation 1. This equation, oops, can't also be number 1. That wouldn't make any sense. This is going to be equation 2. Okay, and what I'm going to do is I'm going to solve for y in equation 1 and substitute that into 2. And it's kind of redundant in this case. It's kind of redundant because we already have both of these are solved for y. So I'm gonna do it in this way, and then I'm gonna solve this one in a different way, just to show you how versatile this method is. Okay, so step 1, I've solved for y. It's already solved for y. Y is already isolated. Y is already by itself on one side. So I've already solved for y in that. So that's my first step, is to solve for y in equation 1. And then I'm going to substitute that y into equation 2. So equation 2 is y equals negative 2x. And we're saying that y is also equal to this. So let's put this y into that y. Okay? So in other words, we are going to get an equation that looks like negative 3x minus 2 equals negative 2x. This is pretty much exactly what we have been doing with the quadratics. That is, when we're solving for quadratics. Solving systems of equations that have a quadratic in it. We're solving for y and then setting each of the y's equal to each other and yada yada yada. So so now I just have to solve this equation. I'm going to add 3x to both sides. We'll have negative 2 is equal to x, and then we're done. So x is equal to negative 2. So x is equal to negative 2. What about y? What's y equal to? Well, choose any of these equations. Let's choose maybe this equation, and we'll substitute x equals negative 2. So y is equal to negative 2 times negative 2. So y is equal to positive 4. So y is equal to 4. And there you have it. We've solved that one. I want to solve this one again. I want to do it again. I want to do it a second time. This time, what I want to do is, this time I'm going to solve for x. I'm going to do the same thing, except I'm going to sort of revolve around x. I'm going to be focusing on x. I'm not going to be looking at y here. I'm just going to be looking at x. Okay? So, well, I mean, y is going to be a part of the equation, but that's not my focus. My focus is on x. We're going to solve for x, and we're going to substitute that x into the second equation. Okay? So let me just write all this out again, or maybe I'll move over here in this direction. Yeah, that's what I'll do. So I'm going to just move right over here. There we go. And where's that question? Question number 5. Okay, so I've got y equals negative 3x minus 2, and y equals negative 2x. Okay, so this time I'm going to solve for x. This time I'm gonna isolate x in equation 1. Okay, and I mean, I'm hoping that you can see I'll get the same answer. If I got a different answer, then that might be raising some red flags. And if I did get the wrong answer, it probably means that I made some kind of arithmetic error. I've made a mistake in my arithmetic. Okay? So, I've got y equals negative 3x minus 2. Okay, so let's solve for x in this one. So we're going to solve for x in equation 1, right? This is equation 1, this is equation 2, all right? So I'm going to solve for x in equation 1, and then I'm going to substitute that value into x in the other equation. Now, just to be clear, like I'm doing this 2 ways, like as an educational tool. I do not expect you to solve these in multiple ways, unless you are asked to. But in general, you can use any method you want to solve these. You don't have to solve them in multiple ways. Okay, so I've got y equals negative 3x minus 2. So let's, I'm just going to write that equation out all over again, and then I'm going to solve for x. So when I solve for x here, let's see, I'm going to move the 2 over to the other side. So I've got y plus 2 equals negative 3x. And now I'm going to divide both sides of the equation by negative 3. So I've got negative 3 over here, negative 3 over there. So now I know that x is equal to negative y over 3 minus 2/3. Okay, so that looks a little bit funky, but you know, bear with me. It's still gonna work. So this is now what x is. I've solved for x, and now I'm going to substitute this value into the other equation, and I sure hope that there is a 3 in there somewhere. Looks like there isn't. That's okay. That's okay. Have I done something wrong here? I feel like I've done something wrong, but maybe not. Oh yeah, it'll work out. It'll work out. It's fine. It's fine. Okay, so let's plug this, whatever we got for x here, let's plug that into this x in the other equation. Okay, so let's go ahead and do that. So I'm going to write out this equation out one more time. So I've got y equals negative 2x, and in this case, y is equal to, well, negative 2 times x, and x we said was this beast right here, so let's put that right into there. Okay, make that arrow look nice. It's hardly nice. Let me make a nice little arrow. There we go. Okay, so I've got negative y over 3 minus 2/3. Okay, so now let's solve for y. So I've got, well, y is equal to positive 2/3 plus 4/3. Okay, that looks good. Oh, and that's 2/3 y. 2/3 y plus 4/3. Okay, let's get all the y's over on the left. So I'll subtract 2/3 from both sides. So if I subtract 2/3, that gives me 1/3 of y equals 4/3, right? Because if I've got like a full y, like one full y minus 2/3 of y, that gives me 1/3 of y left, right? So I'm going to multiply both sides by 3 now, and I'm going to get y is equal to 4. And lo and behold, that's what we got in the old one, right? We got y equals 4. So if I plug in y equals 4 into any of the other equations, that is this one or this one, I should get x equals negative 2. I'd be very surprised if we didn't. So let's try it with the first one. Let's put it back into the first equation. So in the first equation we have well, y equals negative 3x minus 2, and here we're saying that y is 4. So I've got that 4 is equal to negative 3x minus 2. Move the 2 over to the other side. I've got 6 is equal to negative 3x. So x is equal to negative 2, just like we were expecting. So I'm hoping that this is illustrating that these methods are very flexible, and you can basically do whatever you want as long as your algebra is consistent. Like there's no right or wrong way to do this, unless of course you were asked to solve a system of linear equations in a particular method and you used a different method. In that case, well, it is the wrong method because you were asked to do something that you didn't do. But I think we all understand that. It sounds kind of lame, but a large part of mathematics is following instructions. It doesn't sound very romantic, and it doesn't sound very special, but it's true. A large part of mathematics is following instructions, and I hate to say it, but it's the truth. So if you were asked to solve this using substitution and then you drew a graph, well, I'm afraid that you weren't following instructions, so you wouldn't be able to be rewarded the full marks, because your math teacher would be asking you to demonstrate your understanding in a particular area, and you're demonstrating your understanding of something else, right? It's like if your English teacher asked you to write a essay about I don't know, communism, and then you wrote an essay about skateboarding, and it was a fantastic essay, and you clearly demonstrated your understanding of the English language through an essay about skateboarding. You still didn't follow the instructions, and you didn't write an essay about communism, right? So just like that in mathematics, there's many ways of solving the same system. Oftentimes you can choose your favorite method. Sometimes you'll be asked to use a specific method. So it's important to practice all the methods that you see. Okay, let's do one more equation, one more system from the review worksheet, and I'll do this one here. I'll do question 13, number 13. And I haven't received any messages saying that the review worksheet has been a challenge, which tells me that things are going okay. If they're not going okay, if you're having difficulties with the review worksheet, tell me. There's no shame. There's no shame. I think it was Socrates who said that the greatest sign of intelligence is understanding what you don't know. That I can't, like, if there's one thing that I believe about quote unquote smart people, it's that intelligent people, like what makes people intelligent is when they understand things that they don't know. Okay, so if there's something on this worksheet that you don't know, tell me. I'm not going to judge you. I'm not going to think, oh, I can't believe you still don't understand that. I'm not that kind of person. I will help you through it. We'll get through this. But it is really important that you understand how to do this at some point. If you don't know how to do it now, that's okay. We'll get through it. But please tell me, because I can't, like, I'm not going to assign a review worksheet for marks. I'm not going to have it as an assignment. And so it's going to be difficult for me to know if you don't know this. So it's much easier to attack these smaller problems before they turn into big problems. Okay, anyway, let's do number 13. So this one, we're going to solve using elimination. So that's a different method. So let's try this one. It's x plus 3y equals, what is it, negative 13. And the other one is negative 3x minus 3y equals 15. And we're going to solve this. We're going to solve by elimination. Okay, what does elimination mean? Okay, glad you asked. Well, elimination is where we eliminate one of the variables. So here's the deal. I'm saying, like, I just want to tell you how this works. So I'm saying that this thing is equal to this thing, right? Or in other words, x plus 3y is equal to negative 13, right? They are equal. That's what we are assuming. That is what this equation means, is that these two things have the same value. So if I were to do this, if I were to say, okay, well, let's take this second equation. Okay, let's take the second equation. I've got negative 3x minus 3y equals 15. Okay, let's say I took that, and let's say I was like, okay, well, maybe what I'll do is I will subtract 13. So how did I write this? Maybe I'll write it underneath. I'll go minus 13 minus 13. Okay, so I subtract 13 from both sides. That is a perfectly valid algebraic operation, right? You can subtract the same thing from both sides, or you can add the same thing to both sides, right? Now, we assumed that 13 was equal to x plus 3y. They are the same thing. So how about, instead of subtracting 13 on the left-hand side of the equation, what if we subtracted this? Or I guess you could think of this as adding negative 13. So let's add another version of what negative 13 could be. So we could add x plus 3y, right? It's the same thing, right? That is negative 13. It says so right here, right? This equation is telling us that negative 13 is equal to x plus 3y. So how about instead of adding negative 13 to both sides, what if we added negative 13 to one side, and on the other side we added something that was the same thing as negative 13? It just looked a little bit different. That's exactly what we're going to do. So, so the idea here is we're going to add these two equations together. Adding two equations is a perfectly valid algebraic operation because both sides of the equation are equal, so you can add or subtract or even multiply and divide both sides of an equation by the same thing, right? So that's what we're going to do. And why are we doing that? Why, like hold up, why are we adding these two things together? Well, a good question. I'm really glad you asked. Why are we going to add these things together? Well, because if I add these two things together, I will get plus 3y minus 3y, which is 0, right? And that would eliminate, that would eliminate the y's. And then we would have an equation at the end of all of this that just has x in it. And once we have an equation that has just x in it, then we can solve for x. Then we narrow down what x is, plug x back into one of the other equations, solve for y. Okay. Now this method of elimination is actually the preferred method in linear algebra. That's that university course that I was telling you about, linear algebra. Here's a linear algebra book. That's the method that you would do in university, is this elimination method. Except the elimination that you do in linear algebra is a little more sophisticated, and you do that using something called a matrix. Oops! Oh, look at this. I was looking for this book. Gödel's Proof. We'll get back to this question in a minute. Just want to advertise this book for a minute. This is an amazing book. Yeah, I can't even begin to tell you how amazing this book is. This book is about this guy named Kurt Gödel. I don't know how to pronounce Gödel. Kurt Gödel. Let's call him Kurt. It's about a guy named Kurt who is a young mathematician. And oh yeah, look at all these amazing books that I have. Okay, let's just take 2 to 3 minutes off. I have this amazing series of books called the Principia Mathematica, and it's a 3-volume series. Here, let's get all 3 volumes out. It's a 3-volume series. Oh, I got them out of order. 3-volume series. This is it. So this series of books. I mean, there's a cool story about how I got these books, but I'll tell you that another time. So these books were written by Bertrand Russell and what's his first name? Something Whitehead. Alfred Whitehead. Whitehead wasn't nearly as Alfred Whitehead. Wasn't quite as well known as Bertrand Russell. Bertrand Russell, you may have heard that name before. Very famous mathematician, philosopher around the turn of the century, or maybe a little bit later than that, actually, kind of like the early 1900s. Anyway, so this book, just take a look at some of these pages. Like it's bonkers. This is the entire book. It's just like symbols after symbols after symbols after symbols after symbols. It's like you'll never see anything like this. This book is honestly, it's kind of silly. Like the joke about this book is that it takes like 5,000 pages or whatever to prove that 1 + 1 = 2. It's that kind of mathematics where it's really, really like existential and esoteric, and it's about mathematical logic. And the entire purpose of this book and the the Coles Notes version, the gist of it is that mathematics is mechanical. In other words, you could get a computer, you could program a computer to solve every single mathematical problem, and not only that, but discover new problems. And basically, I mean, the long story short is that mathematics is in the realm of a computer, that it's mechanical, and that a computer could solve and discover all of mathematics, and that humans are not actually required to like, they're not really in the picture, that mathematics is all just a like in the realm of a computer, and that computer could discover all mathematical problems, and all of mathematics could be solved by a machine. The machine would just have to be very complicated and strong and that kind of thing. And this book came out, the Principia Mathematica came out how long ago? I think like in 1910. In 1910. And that was, and it was, you know, it was a huge result, and kind of disheartening. Like, I don't know about you, but it sounds like a little bit, it sounds a little depressing, right? That oh, hi, Liam. It sounds a little depressing that you know, humans don't even really play a part in mathematics. That it's just like a computer. You could just program a computer to be like, solve mathematics, execute. And then a few years later, this guy came along, Kurt. He came along and disproved it. And he had like the most elegant and beautiful and stunning proof that hey, all that work, that 3-volume set of crazy mathematical notation and that esoteric mathematics that seemingly no one really understands, it's false. You're wrong. It's impossible. And this book tells that story very well, and it also kind of works through the proof. And the proof is obviously, like, to fully understand the proof, you need like to be quite smart, smarter than me, for sure. But this book kind of breaks it down in a way that you can kind of understand the gist of the proof, and you can be like, oh, okay, yeah, I can see how that could kind of work. And it's really well written. It's a beautiful little expose into something that I think fundamentally changed mathematics. I think that this is, I mean, I'm not a mathematical historian, but I'm of the opinion that this is probably one of the most important mathematical proofs ever. Yeah, so Gödel's proof, you could probably get this for like $10. It'd be a great read over the summer if you're interested in this. Oh, and look at this. This is so beautiful. Look who they dedicated it to Bertrand Russell. I hope that I'm not vilifying Bertrand Russell. You can't see that. He's an incredible human being, or he was when he was alive. You know, I don't agree with everything that he said. I'm not like a fanboy or anything, but yeah, by no means am I trying to vilify him or anything like that. Anyway, I got a little distracted there because when I pulled off that linear algebra book, the Gödel's proof book just fell off the bookcase. I guess it was stuck behind another book, and I'd been looking for it, and now I found it, and I got all excited. If you remind me, and if you're interested, I'll tell you how I got this copy of the Principia Mathematica. It's kind of an interesting story. Anyway, let's get back to this. So we're going to solve these by elimination. So what I was saying before is that all of these, like, both sides of the equations are equal. So if I subtract one side of the equation, I can subtract the other side of the equation, and it'd be the same. I could also add them too, or I could multiply them. In this case, I'm going to add them. I'm going to add them because I can see that I've got a plus 3 and a minus 3 here, and that's really going to help me out, because if I can eliminate a variable, then that makes it easy to solve. So let's add these together, and what I'm going to do is I'm going to just put a line underneath kind of like when you add two numbers, like 23 plus 57, right? You put that line there, and then you add your ones place value, and then you add your tens place value, and then you move on. Oh, hi, Goosey. Say hi to everyone. Okay. So we're gonna do that. Oh, Goosey, no, you can't go right on my iPad. I have to write. Okay. Yeah, see, she wants us to go back to calculus. Okay, so so just like we have place value, Goose. Oh my gosh. Oh, too cute. She's just too cute. What am I supposed to do with this? Okay, just. I know I'm getting really distracted, but it's her birthday, so I can't help myself. You gotta see this. She's just being just so adorable. Oh, Goose. Like, how is someone supposed to work with this? I mean, really. Like, it's a bit much, don't you think? Like, she's just, how can you not? Oh, Goosey. Oh, Goose. Happy birthday, little sweetheart. Happy birthday. Special day. She totally knows it's a birthday, too. She knows. There's some things she knows. Oh. Okay. I'm getting so distracted here. I'm sorry, guys. Okay, so we're going to add these equations together. We're going to do it just like we add place value. So I'm going to add like the constant terms here. I'm going to add the constant terms. I'm going to add the y's. I'm going to add the x's. Okay? Kind of like I'm looking for like terms. So I'm going to add those up. So let's go ahead and do that. I've got, well, negative 13 plus 15 is 2. Negative 3y plus negative 3y, or sorry, I meant to say 3y plus negative 3y is 0y, or just 0. I'll just write 0, right, plus 0y. And x plus negative 3x is negative 2x. So we can simplify this. I get negative 2x equals 2, or x equals negative 1. Great. So now I've solved for one of the variables, and the other variable, we can just choose any of the other equations. Let's do equation 1. So let's do equation 1, and I've got, well, x is negative 1 plus 3y equals negative 13. Okay, I'll add 1 to both sides. Right? Yeah, I'll add 1 to both sides. So I get 3y equals negative 12, and y is equal to negative 4. Okay, there you have it. So there's our solution. We get x equals negative 1 and y equals negative 4. Okay, beautiful. Okay, so I'm going to assign some homework today. So it'll be on some more system stuff. I feel like we've been doing lots of examples. For your exit slip today, I'd like you to solve this linear system. It's, oh, I guess you've already done that one. Give me one sec here. File, open. Here we go, and I'll just generate some new ones. There we go. Okay, so I want you to solve. So I want you to solve this system. Let's do x minus 4y equals negative 5. So write negative 5, and negative x minus 4y equals negative 3. Okay, and you can use this using any system, using any method. Okay, so you could use it using substitution. You could use solve this using elimination, whatever method you like. So yeah, and that's your exit slip for today. Exit slip. Okay, so that's what we're gonna end off on. So it's really nice doing this today. Beautiful day. It's Goose's birthday, and do a kickflip day. What a fantastic day it is. It's also beautiful outside. So if you have a skateboard, maybe go outside, try to do a kickflip, because it's do a kickflip day. And I'm not making that up. You can look it up. It's today, April 29th, do a kickflip day. So if you can do a kickflip, maybe go try. If you've never landed one before, but you've been pretty close, maybe try to keep practicing, and maybe today's the day to do a kickflip, because it literally is do a kickflip day. I will talk to you guys tomorrow. I hope that the assignment is going well. If you need help with anything, as always, don't hesitate to ask. And I will talk to you guys tomorrow. Bye-bye.